Hey guys, got a Gigabyte motherboard here, GA-EP45C-UD3R, and this could be a bit of a challenge because all the low side and high side MOSFETs on the Vcore have been removed, which suggests either that they've been salvaged because somebody couldn't fix this board, or that somebody removed them intending to repair the board and then didn't bother, they gave up or just didn't bother to complete the job. So that's what's missing. It looks fairly tidy. There's something else missing here by the looks of it. The rest of the board looks okay. Just the MOSFETs, and it's kind of like marked as well. MOS high side 1, and there's 3 there, yeah. In fact, it's HS for high side, MOS HS2, yeah. But I'm confident to say that we've got 1 FET on the high side and 2 on the low side, yeah. So I tried to find a schematic for this. I'm thinking, well, if I find a schematic, or even better, a board view, that will effectively tell me what components they are, but I couldn't. So I had a bit of a look around, and eventually on Bad Caps I found a thread with somebody, one of these, and they had some photos up on, and then I could see what the parts are, so I actually know what the FETs are, and I've got some. They're quite a common one. Not sure about this chip, but it'll be the same as these, yeah, probably a driver. So let's have a look under the microscope and let's see what we're faced with here, and see if it's something we can perhaps have a go to actually repair it, yeah. Just get my trip camera on, hope it's working. Oh, it is, that's good. That's good. So these, where are they? I've moved the camera a little bit. Okay, yeah, this is the where the MOSFETs are. Let's just adjust the focus slightly. There you go. Okay. So having a look at this, you can see. Just one moment. Sorry, I thought there was somebody at the door, but there isn't. I am expecting somebody shortly. The guy picking up his radio mic and his whatever it was I fixed on the last video, voice processor or something. He's a musician singer, yeah. So anyway, before he arrives, let's have a quick look at this. So these are going to be the high side FETs, and these two are going to be the low side FETs, yeah. And the FETs AO2726 and AO2724. I got the information off Bad Caps, yeah. This has obviously been removed here. What I want to just have a look to see is if anything else seems to be missing. Like for instance, looks like there might have been something there, yeah. And I think probably the best way to do this is try and like compare each of these phases, because they should all be basically the same. So I can see on this one there's a capacitor here, there's 2 other, that might be a resistor, that's a 2.2 ohm, 2R2 it says on it, yeah, and that's a capacitor. So comparing with this one, we have the same. We have a capacitor here, we got an extra capacitor on this one that wasn't on the other. We got the black looking thing that might be a resistor, 2R2, 2.2 ohms, and a capacitor. So that basically looks the same as this one, albeit it's got an extra capacitor. Another one, yeah, so we have the capacitor, the black thing which could be a resistor, 2R2, and the capacitors. So we say those are probably okay because they're identical, yeah, which would suggest that nothing's actually oops, sorry, microscope camera froze on me. Okay, yeah, so we can tell these across the top, they look identical, the grouping of the components. So we know what we have on those, yeah, and they're okay, they look the same. So coming down this side, we should have a similar thing, maybe the layout's different. So let's have a look. So this is the first group, yeah, high side, 2 low sides, yeah. So we have the big capacitor, the black thing in the capacitor. There's probably a resistor missing here somewhere, because they had them on the top here, yeah. They had these 2R2s, that doesn't have one. So the next one below it, I'll probably tell us better. Okay, yeah, I can see it as well. So capacitor, 2R2, and the little black thing in the capacitor. So we see clearly that here should be a 2R2 resistor, 2.2 ohms. Yeah. Let's just go to the bottom one. Oh look, this has an extra capacitor like the first one did. Yeah, you know, so the very first one had an extra capacitor there. Yeah. Yeah, so the phase 6, if that's what it is, if you're in order, is the same as the extra capacitor. Yeah, that's interesting. So it's kind of like a mirror image of itself, really. Okay, so there we have capacitor, the 2R2, the black thing, and the capacitor. So we know for sure up here we have a 2R2 resistor missing there. Yeah, we can say 99% that's missing. Yeah. What's in this bit? The other thing that's been taken off. Okay. So this looks a bit messy. Down here looks a bit grubby. So let's have a good one. So we got looks like a transistor. The chip is a I6609. Oh, right. This little I emblem, that's a company called Intersil. I've seen this emblem before. I think if you went and looked on the internet for 6609 datasheet, it's going to tell you this is an ISL 6609. And it's a MOSFET driver, I'm pretty sure. So that's what it is, ISL 6609. I'm sure you could find that if you just went and googled for 6609 datasheet. And we can see here we have a transistor, we have a 1R0 and 2 capacitors. This doesn't have the transistor, but you can see there's something missing here, and that's the 1R0. Yeah, the 1R0 resistor. In one of these two places, but I'd say in that one. We might be able to track out where it's connected to and compare, and then we have the 2 capacitors, and this is the chip that's missing. Yeah, so that's the 1R0 missing, so that's 2 resistors missing. Okay, we have the same again. Yeah, so the resistors in the same place, so you can say for sure that's where it goes. This has the transistor again, 2 capacitors. I'll double check because these have the transistor and that one doesn't, and it also looks like the component might have come from here rather than there. So but by finding out where these 1R0s go to, connecting to this chip, I'm sure they will do, or to the FETs, I'm pretty sure we can work out where that should be. What have we got on this side? The transistor again, the 1R0, 2 capacitors. The transistor again, I thought it was missing, it's there. The 1R0 and the 2 capacitors. Yes, that is the 1R0 in a different place, so that means we do need to check that other one. Capacitor 1R0, 2 capacitors, yeah. And that one doesn't have the transistor. Okay, much the same as the way that this had the extra capacitor, yeah, and the first one had the extra capacitor. This one and the other one don't have the what was I saying? Yeah, the layout isn't the same. Yeah, they don't have it the same. Okay, so we know what the chips are. Yeah, I've got the parts of this because they're quite common. From bad caps, I've found out what they should be. So we're gonna have to replace 3 resistors, I think it is, that's missing, a couple of 1R0s, a 2R2, and the FETs. Yeah. So what I think we'll do is we'll do this phase on the video because it's the most difficult one anyway. It has this chip, yeah. And then once we've done that, I'll then go offline and do all the rest, and then we'll come back when everything's replaced, and we'll see what this board does. Yeah. Okay. So let's start soldering. So I'll just put the soldering iron on, get ready so we can do some work. I do have the parts, so the 2726 are here. I've got some of those, I've got some of the 2724s here, yeah. I've got the ISL 6609s, I've got quite a lot of these because they're quite common. So that's the parts we need. I'll definitely have resistors, so that won't be an issue. So the first thing then is going to be to clean up this area. So we'll clean this up. We'll get the chip back in, yeah, 'cause that's going to be the fiddliest place. We'll get the high side and low side FETs on, yeah, and then once we've done that, we'll have a look on the next phase to see where this 2R2 resistor connects to, because I'm sure it's going to go to this chip or one of the FETs, and then we'll know where it should go on here, yeah, with these two places. I mean, according to the layout, it should go to the one just below the capacitor, but it looks like it might have come from there in actual fact. Okay, so we're going to need some flux, yeah, first. Get some flux in here. I don't know if this chip has actually been cut off, you know, all the pins cut off and just left the legs there rather than actually being properly desoldered, yeah. Get a little bit of water for the sponge. Let's see what we can do with this. I do have, by the way, you can probably see here, yeah, in the camera, I do have the heat sinks off this, so they did come with it, they just weren't fitted, yeah, so I have them as well. The FETs we can remember because the 2726, which is the highest number, is a high side FET, yeah, and the 2724 was a lower number, is a low side FET, so there's not going to be a problem remembering which ones go where, yeah. Okay, so if I've waffled enough about that, or we've been through all the interesting stuff, so let's see if we can clean this up and whether we actually have any residual bits of component leg. I'm going to look down the microscope now because it's a lot easier for me to do this. I'll just set the focus exactly right for me, and then I'll set the focus exactly right for you as well, and then we can get on with it. Okay, that's looking. I think that's good. Right. I can't work without stereoscopic vision. If you've watched enough of my videos now, I've told you don't buy USB microscopes. I can't do this sort of work with them. I mean, I've tried. But that's all yucky. It's coming off, but it's not very nice. Let's just get this off and let's put some fresh solder on. Oh, this side's better. Okay, just get a bit of fresh solder on this and then do it again. I don't think that anything was stuck, you know, like component legs. I think it was just like effectively just nasty bit of old solder on there. Let's try this again. That's hot now, is it? A bit fiddly getting in here because of these capacitors. Still, I'm sure we can do it. Okay, I think that's clean. Just on this, there's a bit of something stuck to that. Maybe a little bit messy. Let's just go over these and tidy it up. Yeah, some leaded solder. I'm not sure what is on this at the moment. Hey, yeah. My field of view through the microscope is considerably wider than the camera as well. That's why sometimes I go off, you know, off the edge. Basically, you can't see what I'm doing because I'm not seeing exactly what you were seeing. Okay. Solder to that. Yeah, that's some solder. Okay. Okay. Again, it's got a bit of solder braid in here. Clean it up nicely. I want to leave a little bit of solder on the pad, so it helps when I'm soldering the new one. Yeah. Going on this one. Now I think I need to cut the end after braid, it's got a bit flooded now, yeah. So it's all becoming a little bit flooded. Solder, okay. Let's go in on this one. Yeah. Okay. Quite clean. Okay. That was nice. Something missing here. I don't think so. I think it's, there's nothing missing there. I'll look at the next one down. It's just as I've accidentally cleaned the pads. Okay, so fun's going to be getting this chip in here. This is the fiddliest place to get out. Yeah, this capacitor wants straightening up, but I'm sure it's in. So on the chip here, you can see there's like a notch there. Yeah, so that indicates where pin 1 goes to the left of that, and then we count anti-clockwise. So let's get a chip. Yeah. Let's have a chip. Okay. So on the chip you can see that there's a dot. Can you see? I thought the microscope had frozen, but it hasn't. There you go, I'm just off view for you. Let's just position this so it's in the correct position on the pads. Rotate it a little bit. There. So you can see there's a dot here, yeah. So that goes to the left of like that notch. That's where pin 1 actually is. So it's moving upwards very slightly. There we go. Easiest way to do this. A bit of the thin solder, yeah, the 0.2mm stuff. With a bit of luck, that will just stay in position. So I've got both hands free. Just bring a little bit of solder onto this pad. And solder one leg. No, can't get at it. Oh, sod. Damn thing doesn't want to solder. Let's try a bit more flux. Surprised at that. I thought that would solder quite easily. So I'm bring the soldering iron in the other way. Yes, I've actually got the flat side of it against the board. Get a bit more heat in. Yeah. Oops. Now I've moved it. Okay. Okay, but we've got a bit of solder on the tweezers. And I've straightened it up. So that's nicely gripped by one leg, it's going nowhere now, yeah? So we can get a little bit more solder. I'm in view, yeah, you can see me good. Just push down the chip. That's soldered in place. So you see it's very fractionally out, but that's close enough, yeah? Nothing's going to short. Or if you want to be exact, we could probably straighten that up a little bit, but how determined am I to do it? How perfectionist do we want to be? Yeah, straighten it up a little bit, yeah? So that's down. Make sure this one's down, yeah, that's down. Yeah, go on, bit of perfectionism, eh? Bit of professionalism in there. Solder it straight, yeah, okay? You can see the amount of heat I'm having to get in to do this. This is why you don't want to be using a fine tip soldering iron. Yeah? You just cannot get enough heat in to do the job. The other side is going to be more difficult. So turn it round so I can come at it from the other direction. Okay, let's see if we can get in between the pins and do them one at a time coming this way. Obviously these capacitors are in the way. I may have to take the capacitors off, but let's have a go. To actually get in there, not well. I've got a solder bridge, so I'm not bothered about that. I'll soon clean that off. Sorry, I'm just going out of view again for you guys. This is because the angle I'm having to come in at to do it is not ideal, especially with the microscope in the way. Can't get to that one. I've now got a big solder bridge. Don't worry about it, let's get a bit of braid. Let's get a bit of braid before it all goes horribly wrong, yeah. A little bit of flux, a little bit of braid. Just deal with this. Clean the soldering iron tip. So we're getting at it from this direction. Okay. There. May I start with a little bridge in the middle? Not a problem. Not a problem if I have. Because I ain't now. In fact, that's helped a lot. That helped a lot to solder it. Let's try and come in from the same direction with the solder. Yeah. What an awkward position for this damn thing. I may end up using a bit of hot air, you know. In fact, I can't see because of the soldering iron. Let's try it again. I think I've got it. Yeah, I think I now have it. I'll use the test meter to actually check if that's soldered to the pads. Yeah. Okay, let's get a bit of flux and let's clean that up and see what sort of job we did of that. Sorry, I meant a bit of isopropyl, not a bit of flux. Yeah. Let's get a bit of isopropyl and see if we've done a decent job enough of this. Awkward little place to get with that, I think it was. No. Just cleaning the whole area really. Okay. Bit of kitchen roll, yeah. A bit of old kitchen roll. Glasses so I can see what I'm doing. Okay. Let's see what we have here. That was soldered to me, but we can kind of check this, yeah. So we'll get the multimeter. Let's put it somewhere where you can actually see it. Yeah, that's why I've had this camera propped up at the side here for you. Okay, so just multimeter there, yeah. And we're on continuity mode, so a little bleep, yeah. Yeah. And what I'm going to try and do is check from the pad. So I'm going to try and touch the pad, but not touch the chip, yeah. And then touch the pin. Yeah, that's connected. That's definitely connected. There's a big blob of solder down. Same as that one. This one, I'm against the solder, and I'm against the leg, yeah. So you see, I'm effectively trying to touch just where it comes on the pad. That's got quite a blob of solder on. That's got quite a blob. Yeah, those are looking good. Okay, so that's that one. Now we need to put some of these MOSFETs on, yeah. So let's do the high side first. I'll just get the part. So there's the part. This is the A2726, yeah. And you can see if you look underneath it which way round it goes. So you've got this pad which is for here, obviously, and the 4 pins for here, yeah. So I think the easiest way to do this is let's try to get a bit of solder, just a little bit of solder on all of these, yeah. But at the same time, I want it to sit quite flat. I don't want like a lot of solder. I may end up having to wick this back off to get it to work. Let's just check the focus as well, just make sure exactly yeah, it looks pretty good. Focus on this is far better than the focus on the overhead camera, yeah. Why that drifts out, I don't know. Okay, so what we found, soldering iron tweezers. I'll put down here. Yeah, so I want to try and get like just a very small amount of solder on the pad. Right, so I mean like a very small amount, yeah. Just clean the end of the iron. Something stuck on that. I think it was a bit of solder braid, you know. So a small amount of solder on there, and the same on these 4 connections, yeah. Okay. And then let's see if I can tin these as well. So tweezers, yeah. A little bit of flux without this, to be quite honest. A little bit of flux without this. Don't want too much. Probably got too much. I didn't want too much, and I probably got a bit too much. Slimy thing stuck on the end of the soldering iron. Didn't want that to happen, to be quite honest. Hope it survived. Get off here. Huh. Thing stuck on the soldering iron. I think we better just test that to make sure it's okay, you know, after it was stuck in the end of my soldering iron for quite a few seconds there, yeah. Way to test this. Go to diode range. Okay. Now, this will be the source or the drain, yeah, and one of these 4 pins will be the gate, and the other 3 will be the drain or the source. So that's reading like, right, that's the gate because it's reading nothing, yeah. Now this is a good one. I'll show you why. Let me just turn it back over again. Turn it back over. Let's make sure you can see. Yeah. Okay. So this is now turned on. Let me turn it off, and you'll see how I'm doing it. That's the gate. Yeah. So see that bleep? Diode junction. Diode junction. Diode junction. That's the gate and source. Yeah. If we put the positive on the gate, it's now switched on. Whichever one the gate is. It'll act like a short of the gate, right? Yeah. Okay. Just positive to there. But that's making no difference. Right, let's try it the other way, yeah? That's now turned on. That's the gate, yeah? Should be turned off now. See, it's off, yeah? Nothing happening, yeah? Positive to the gate, yeah? Should now be turned on. Yeah? Let's turn itself back off again. Probably I just caught the thing. Yeah, it's turned on, yeah? Negative to the gate. It's turned off, yeah? So that's a good FET. So basically just touch the, this will be an N type, just touching the positive to the gate and then the thing switches on, yeah. Touch the negative to the gate and it switches back off. So we know it survived its little trip onto the end of the soldering iron. Okay. What do you mean power FETs are designed to take a fair bit of heat? I mean they're not quite meant to be as hot as that, but they are meant to take a fair bit of heat. So let's just flip this over the way up and we're ready to solder it on, yeah. Make sure I've got it the right way around. There's a dot on it actually. Was it the right way around? No, it was the right way around. The little sod. Yeah, it goes that way. So it goes the dot downwards. So for the other ones I'll know which way it goes, yeah? Yeah, so position it on here. And now I'm going to try to hold it in position and just tag one corner pin, yeah, to the actual pad. Once I've got one in place, it'll be quite easy. I'm doing this left-handed, which is not my best hand, but let's skate. Let's skate. So there's our FET, yeah. It's in place, yeah. I'm going to try and tag one of these corners down. There we go. Okay, that's got it. So you see, the pins are almost lined up. I just moved a little touch. I mean, it's fine as it is. It's not. It's because there's little bits of solder on. That's all it is. Okay, that's in place. If I now heat this up with hot air and just press it down with the tweezers, this will solder. Yeah. Let's just do it. Yeah, you see it go. You see that? All the solder melted, yeah? You see all the solder melted, yeah? It's actually squirted out a little bit at the side. We can see it, just clean that up. So that's basically the way I do them. I mean, and no doubt other people will have their own slightly different methods. There doesn't matter there's a short there because all these 4 pins are connected together anyway. What I will do, I'll probably clean that up just for the sake of it, yeah. Get a flux. What I will do is now just check to make sure that I haven't got a short. But obviously when I pushed it down, the solder underneath it kind of like squashed out slightly, yeah. There you are. Looking a lot better now, isn't it? Looking a lot better now. Okay. We need to make sure we haven't actually caused a short by doing that. Sorry if it was slightly off view. Okay. So. Nope, just use like a diode junction. Yeah. And this will be the gate. So it doesn't read anything. Yeah. Okay, so that's them done. We just need to do the 2 low sides and then we'll figure out where this resistor is supposed to go. Actually, I will just check, you know, I've assumed that these 3 are the high side and these 6 are the low side. And that's just because that's the normal way they're laid out. But before soldering any more, let's just be certain. So if we go from 12 volts coming in, yeah, which is on here. Okay, one moment, so we're at the door. Yeah, sorry about that, somebody at the door again, but he was paying for a job, so that's fine. Yeah, so if we go for the 12 volts, if this is the high side FET, then one side of this FET should go to 12 volts. That's why it's called high side. And it is, that side is, yeah? There you go, yeah, that side is. So the other side of the FET, being the high side, will go to both of the low sides. Probably, yes, here and here, yeah. And then the other side of these low sides would go to ground, yeah. You would expect. Yeah, it does. Just couldn't get a good connection at first. Yeah. So that is definitely the high side FET, yeah. So what I'll do is now I'll solder the two low sides. It's going to be exactly the same method I used for that. So I'll do it off camera, save your time. And I'll just go down all the rest of them, and we'll put them all in, and then I'll come back to the recording and we'll just check these missing resistors and make sure that they are where we think they are, yeah. Replace them, and then we're ready to go. Okay, see you soon, guys. So guys, I've replaced all the FETs. You can just have a look. This is the top row of them, yeah. You can see the 260 at the top of the 2.4s are underneath, so they're all correct. This MOS HS1, I realised later, it wasn't MOSFET high side, it's heatsink HS1. I'm thinking we heatsink, yeah. Just I just thought about it later. So they're all soldered in. I use the same method as the one I showed you, and if we just go down the other side as well, yeah. So you can see again the three, one high side and two low side, all soldered. So what we've got to do now is just figure out these missing resistors, yeah. So focus on these top ones here. We have here the 2R2, yeah, a little capacitor, a little black thing. So a little black thing and the big capacitor, yeah. And again 2R2, little capacitor, little black thing, big capacitor. So they're all okay. Again on this one, everything there, yeah, with the 2R2. And then we come down this side, and the layout's different down the side. And this is the one I'm sure has a resistor missing, probably from here. So there's the little black thing, there's the capacitor, yeah. The big capacitor, probably one of these around here somewhere. Oh no, there's the big capacitor's there, yeah. Now if we look at the next one, this has the 2R2 in here, yeah, which seems to be missing. Little capacitor, black thing, big capacitor, and then the last one, again, 2R2. So I would say with confidence, really, that's what's missing. But we can just check that. If I go from this 2R2 resistor here, yeah, and it's connected to one of the MOSFETs. Connect here, yeah. So the other side obviously will be 2 ohms, yeah. So if we look at the one that's missing, we can just do the same. So this is where it's connecting to on the other one, yeah, here. And I'm guessing it goes to this pad. Yeah. Obviously this won't read the 2 ohms because it's missing, yeah. So we need to put a 2 ohm resistor in there. So that shouldn't be too difficult. Just a matter, if we get the solder off the pads first and then put leaded solder on one pad, I should be able to offer that up. Might be easier from one direction or another. Let me see where the flux is. I've got some flux. Okay, so this is where the thing belongs, yeah. So first of all, let's just clean off the old solder from here, yeah. I'll look down the microscope, it's easier for me. Okay, just get the crap off the end of the soldering iron bit. Okay, so this is where it actually goes. So I've just taken the old solder off. There we are, one pad. Off the other pad, yeah. I'm now going to put a bit of fresh solder, leaded solder, on one of the pads. I'll probably come in from this direction. Let's have a go. So a fresh solder on one pad. Now we need a resistor. So these are 0603 is the size, yeah. Got a little bag of them here, yeah, 2R2 resistors. So let's get one of these, and then we're ready to replace this. So these are the actual replacements, yeah. They marked 2.2, slightly different markings, but probably 2.2 basically, yeah. Where can we get this out of here from? Let's have a look. See if we can just lift up the tape slightly, a little bit fiddly these things can be. Okay, I've got it. So let's have our replacement. Come out, you little beggar, one moment. That always seems to happen when I'm on live video or recording video. When I'm just working on things, like I was replacing all those FETs earlier, I don't seem to have that stupid sort of thing going wrong. And of course, as soon as I actually try and do it on video, I look stupid, yeah. Okay, I think the best way to do this is come in and turn it round. So we're coming from the direction we want. And I can't turn the board that way because the microscope stand, well not a stand, but the things behind it are in the way. Okay. Which direction can we get this at? Let's have a look if we can do it this way. Okay. So, yeah, we sent it on the screen for you. Let me just check that focus as well, just see if it's just right for you guys. Okay. So, try it. Soldering iron left-handed, I'll have to come in from the other direction. So soldering iron in from this end. Resistor. Melt with a bit of fresh solder. I should just put a slide this in place, there we go. Slightly crooked, but it's good enough. No, it's pretty straight, that is. Okay. So that's got one of them. That's our 2.2. So we can just check now. They should all be present and correct now, yeah, on each channel, each phase. A little bit of solder from this end. I'm going to be careful that I don't actually desolder the resistor again, yeah. So solder it in place. There we go. Bit of a blob, but I've got it. Okay, so that's that resistor fitted. So we've got the 2.2s. Now we had at least one of the other resistors missing, the small ones. This is down here. So we're in this area. There's a resistor missing here. If we look at the other ones again, we have a capacitor or something, a larger capacitor. So capacitor, larger capacitor, resistor, yeah? And then like an empty space. Capacitor, capacitor, resistor. These have these transistors on them, yeah? Coming down this side is slightly different, but we have the transistor, resistor, capacitor, yeah? Transistor, resistor in a different position on this one, yeah? Capacitor, capacitor, resistor, another capacitor, and this one doesn't have the transistor. So I want to figure out now where these resistors are actually connecting to these 1 ohm, I believe they were. Let's look at one of the ones that's actually present, yeah, the one that we've actually got on the board. So I'm kind of guessing this resistor is connecting to the FETs or to this chip, yeah. So here's one of the resistors. Where's it go? Need my glasses to see the meter. This is going to be fun. I can't use the microscope with my glasses, that's the problem, and I can't see anything else without them. What we have here? No, it's not going to there, I thought it was. Let's put it onto continuity mode, I can hear it bleeping, yeah. I think it already is. Let's go from the bleep. This time I can't use it without my glasses, haha. That's a good thing with meters, that bleep that is. So, there's a resistor. I want to see where this goes. I want to figure out where that's connecting to. No, not usually. Oh, it's not the resistor, this is the resistor. Look at there. can get from the other end. It's only 1 ohm, so it'll be almost 0. Something's bleeping. Okay, that's where it goes to, yeah. That's where it goes to. So let's look on the channel with one missing. So it goes to this leg here, yeah. And that will go to one of these pads somewhere. You would expect, I'm sorry, this leg. Yeah, it goes to this pad, so it's the same place. That looks like it can go to either. So where's the other end of the resistor going? I'm assuming one's the resistor ones, because this goes off up here somewhere. Let's go to the FET. No, I'm not sure where that actually goes to. And you can't see a track running off on this one. I think I'm going to go, I'll take a bit of a guess on this one, that it came from here, you know, effectively the same place as the other one came from, yeah. So I'm not sure where the other end of that resistor actually goes to, and being a low value resistor, it's not easy to tell. Where's this one? This is the other one. Yeah, and once again goes to this chip. Where's it going? Yeah, I'm not sure where that actually goes to. Let's take a guess. Let's live dangerously, yeah. So I need a 1 ohm resistor in here. Are there any other missing? That's okay. That one's okay. This one's okay. This one's in a different position, but it's there. And that one's there, yeah. So yeah, it's just so we just need a 1 ohm resistor. I think this is a 0402. Let me go see if I find one. Okay, so I have like a book of resistors, yeah. Get these off AliExpress. It says 0402 as the size, but they can be a bit confusing these because you have like imperial sizes and metric sizes, yeah. And like 0402 exists in both, but like so in here is just like lots and lots of different values, a strip of each, yeah. But sometimes you're not sure what you're buying, so you get like 0402 because you're thinking it's a metric and it's imperial, which I think is an 0201 in metric. And this is the next size down a half. So the other one I had was too big, yeah. And this is the next size I have, and I think these might be too small, but it's what I've got. So there's a resistor. And we want to put it here. And that is, I'm sure like there's a size in between these two, and I'm going to have to get myself some. But for now, it's just a 1 ohm resistor. Let's just stick it in, yeah. See if I can actually get it onto here. It's going to be a bit fiddly, this is, but let's see if I can do it, yeah. By the same sort of method as the other one, and I shall make a note to get myself some 0402 resistors, because I don't think these actually are, yeah. So this is going to be awkward because the capacitors are in the way. So I think I'm coming from this end. So again, got some fresh solder. Ouch, just caught that slightly, but not long enough to burn. Yeah. See if we can get in with this braid. Okay. So I've touched the solder now with my finger. I've touched it with my nail, but not enough to burn, yeah, fortunately. Now where's the resistor gone? That's interesting. Misplaced. I mean, I've got loads more of them. That's the issue. The problem is, where is it? Is what I'm more interested in. Is where is that resistor? It was around here, so I sort of left it lying around, didn't I? And now I can't see it. Oh, it seems to have gone walkie somewhere. That one does. Interesting. Okay, well, let's stick another one in and let's give this board a good shake and knock around. Yeah, see if we can just dislodge that, because that'd make a nice short circuit to go somewhere, that would, if it's around on the board. where you don't want it. So let's see if we can go this way at it. Okay. Straighten out a bit of solder. So we're coming from this end. So we've got a blob of solder on there, yeah? Let's get a resistor. Not sure where that one is at all. Okay, so I found another resistor. So at least we can put this on. Where are you? There it is. This is the replacement one. The other one's probably on this board somewhere in this area, and probably when I play this back just to review the video for uploading, I'll probably see it. That's what usually happens. Some of you are probably shouting at me saying, this is what happened to it, or that's what happened to it. I'm sure when I play this back I'll realise what actually happened, yeah. See if we can just move the meter, and so I can just get this board in a direction I want to actually work on it. So I say this is physically too small, but it's what I have. I doubt there's a lot of current flowing through this, so if it might just burn. Well, let's have a go. Let's have a go. You've got to go with what you've got sometimes, yeah. They're not hard to solder, by the way. As you can see, they're not difficult to solder, these things. Step from in from the other side. Find my solder. The problem with this is you have to hold this in place, because chances are it'll melt the solder at both ends when you do this, and it'll stick to your soldering iron unless you get a good grip on it first, yeah. So I've got it. There we go. So that's how you solder them things, with a big chunky soldering iron, yeah, 10 times as big as a resistor. But you can see you don't need a fine tip soldering iron to do fine micro soldering, yeah. You don't need a micro tip. I think you've seen that now many times. Okay, so everything looks good under the microscope. Let's go back to the desk cam. Let's just zoom that out a little bit, get the focus. Yeah, okay. So everything's back on the board, yeah, as far as I know. I mean, no idea what else is missing off this. I've no idea what condition this is in. This is my resistor book, by the way, which you couldn't see easily. So I've got every value from 0 ohms up to what, 10 meg, and there's many values in this. But as I was saying, this is marked 0402 on here, yeah, if you can see it. But there's no 402 millimeters, which basically means it's 4 millimeters long and 2 millimeters wide. There's no 402 imperial, which I think is it 400ths of an inch by 200ths, whatever it is. But an 0402 imperial is like an 0201 metric, 2 millimeters by 1, yeah. And I'm sure that these are 2 by 1. I've never actually bothered to measure them. And the other size I had were 0603, yeah, 0604. So I need to get some proper metric 0402 resistors. You can buy these off AliExpress, a whole kit, yeah, that's the way to buy them. Same with capacitors. You really need them in all the 3 sizes, probably bigger ones as well sometimes. So you'll have to build up yourself a nice stock, basically. Okay. I can just see in the socket there might be 1 or 2 slightly bent pins. So let's have a look at that. I think you can probably see them there, yeah. Let's just see if we actually have any bent pins in the socket. Right. I'll look down the microscope because it's easier, as I say, for me to do it this way. So let me see what we actually have. So all these in the top look okay. You'll often find this, that you see bent pins, but when you get the microscope, they're not very bent. I'm sure there are some somewhere in here. Where can I see it? Okay, I can see some of this in this bottom end, towards the bottom on this side somewhere. They look pretty much okay. yeah, this is the sort of thing you can see. Let me just show you. You see this one here, yeah? So it's reflecting, it's slightly pushed downwards, it's not bent as such, but it's just down enough to alter the way it reflects light. And that's effectively what you're seeing, yeah, when you look with the naked eye. You're seeing the reflections different. And this is why they look like they're bent when they're not, yeah? See that may fractionally to one side, but nothing to be a problem. So that one there might be a slightly bent over, but again, it's really not going to be a problem. Yeah, well, that looks pretty good to me. That one might be slightly upwards, but again, it's not a problem. Okay, I think we can go with that. Okay, so last thing we need to check is any crap on the desk that's going to short things out. That's a good one. Have we got any shorts on Vcore? Let's just zoom this overhead camera down a little bit. Yeah, so Vcore. So we've got no processor in here, so we should read from 12 volts to Vcore, which would be the junctions of these three FETs basically. Yeah, it's high, or it's like a capacitor charging, so that's fine. So there's no short from there. Yeah, let's go from ground. Yeah, so ground, I'm just on the thing here. Yeah, ground to again the junctions of these FETs. Slipped off. Okay. Yeah, capacitor charging. So there's no shorts on Vcore. Yeah. Yeah. Other end of these FETs will go to ground. Yeah. And the top end of this one will go to 12 volts. And the same for all of them, yeah. So that looks all right. There's no short circuits there. I think the thing with this now is just going to be to put my least favourite 775 CPU in the slowest one I've got, and now let's try this. Let's see if it actually wants to boot now after all that hard work. So we're just about ready to go, really. Got the power supply on. Now there's a processor in. I put it's a dual core 2.2 gigahertz E2200, and I just went and just googled for this motherboard model CPU list, and I just checked the compatibles, and that was on the list, so that should be good. Now we've got the CPU in. If we just go to Vcore on the junction of FETs, we now see the resistance of the CPU 7.7, which is fine. So I think we can get rid of the meter now. I've put my post analyzer in here, so let me just position the camera so you can actually see the post analyzer. Yeah, I think you can see that. I've checked for under the board, there's no stray bits of wire or anything to short it out. One moment. No, always somebody on the phone, just at the wrong instance. Yeah, so everything's ready. I've got no RAM in. I've got no monitor attached, just the board with the CPU, which I know is compatible. No shorts that appear to be obvious. So we can switch the power on. You can see the post analyzer. Let's wait actually does. There's no heatsink on the North Bridge thing. Maybe I should just rest something on top of that. This is the thing as goes. Yeah, just rest it on there. Let's see what happens when we press the switch. And the answer is nothing. Nothing happens. That's what happens when we press the switch. Let's just check if we have some voltages on this. Yeah, coming in on here. So we get the yeah, you can see that. Okay. Well, there'll be nothing on apart from standby. We got standby, yeah. So what's on the green wire? This is the one that starts the thing. Yeah, 5 volts. That makes sense. What's on where the power switch comes in? I'm assuming this is this is the power switch. Should have 3.3 or 5 on it. 5. That's on there. So this should start. Oh, there's no Cmos battery. I'll fit one. I doubt that's what's stopping it. Let me get one and fit one though anyway. Okay. Sorry about that. Let's fit the Cmos battery. While we're at it, let's just check the current on the Cmos as well. This gives us some indication if the real-time clock is running. Yeah, it won't start without it. I mean, the real-time clock should run anyway from the 5 volt standby. So let's turn off the power supply. I'll just disconnect that for a moment. Yeah, let's have a look what we've got. So microamps. I'm expecting between 1 and 10 microamps, I would imagine. So positive to the battery, then a negative to the little clip, and push it back, yeah, to break the circuit so the current goes through the meter. 3.8, yeah, that looks good. So real-time clock's running. So put this into position again. Okay. See what it does now. Power's back on. Where's my little switch? Switch is on, yeah. Nothing. Nothing. Now, amongst the bits I got with this board were 2 little metal screws. I think I got the heat sinks, there was a couple of metal screws and also a crystal. And I didn't know whether this has come off this board somewhere. I mean, I had to quite a look around and I couldn't specifically see that's come off the board, but I wonder if this actually belongs on the board or if there's something wrong with it. I think we know now why all the MOSFETs were removed, because there's it's not starting for some reason. Let me have a look around and see if I can figure out if that crystal actually belongs on it somewhere. Okay, I've had a good look around. I mean, this was rattling around in the box basically with the screws, so that's why I put them in that. But I don't think it actually belongs on here at all. I mean, there's a crystal here in this area. I'd expect them to be one somewhere near to the Super I/O. There's another one here, 2. There's another one here, 3. This will be the real-time clock, and I'm sure that's running because the current draw from the Cmos battery seems correct. So that's I'm not sure that's even anything off here. Also, I mean, I've had a good look around. I can't see where that's come from. I've had a look underneath the board for any soldering. I can see somebody's had flux or solder. That might be a good idea if something's been removed. I can't see anything. So I think we're gonna have to try checking a few voltages and see if we can get some idea why this might not be working. Yeah. So we've got 3.3 volts on the on-off switch. Yeah. That's here. Or 5 volts, whichever it was. 5 volts. That's good. Yeah. So we must have 5 volts or some supply down at the SIO, otherwise it can't start. Without looking for a data sheet, if I look around here, there's a number of capacitors around it. I'll probably find the supply voltage somewhere. Yeah. Let me see if I can actually find something with 5 volts or similar. Yeah. If I can't, then I'll have to see if I find a data sheet. Which range am I on? I'm on volts. Yeah. So I'm expecting somewhere down here to be some sort of supply coming from the 5 volt standby. So I'm just going on each capacitor in turn to see if I can see something, yeah. I mean, so far, no. I probably need now to find out if I find a datasheet for this chip. I honestly thought if there was a voltage supply to it, I'd see it somewhere on one of these capacitors, yeah. Okay, so it's possible there's no supply down here. If there's no supply down here, it's not going to start. It needs to have 5 volt standby or 3.3 volt standby somewhere down here, yeah. Let's have a look down. This is the north bridge. I'm expecting this would have some standby voltage somewhere on it. Again, the easiest place to look is on the capacitors, yeah. And I'm going to use the magnifier so I know you can't see exactly where I am, but that's what I need to do, yeah. I can see how they are. I can see how they are. So these look like the capacitors. I've got a 5 volt standby, haven't I? Yeah. So that. I'm expecting that to turn up somewhere down here. No, I would expect that to have some supply, and I also thought there may be some sort of standby supply around by the south bridge. Yeah. So does see anything down here? Just again, I'm just looking on capacitors in the area to see if something's showing some voltage. I keep convincing myself that I've got 5 volts. Yeah. Yeah, that's 3. Got something here. .09. Is that 3.09 coming from the Cmos battery? 3.29. Hard to say unless we just switch the power supply off and have a look. Yeah. Yeah, that must be coming from the Cmos because I've now switched the power supply off. Yeah, that's got to be coming from Cmos battery. It's like I can't find any particular trace. So I found something down here that shouldn't be in there. That's for sure. At least solder braid, and I've kind of like knocked this board, you know, tapped it and bashed it, looking for that stray resistor that went missing, and obviously that was still stuck in there. You can't be that simple, can it? Can't be that simple for sure. Because I won't know if it starts now. I haven't got the fan attached. No, nothing happens. Let's see if we can force it to start. Let's see what it does. Yeah, power's on, fan on. So to force it to start, we just need to connect the green wire coming in on the ATX to ground. Yeah, I'll just find something. My favourite's one of these 2.22 ohm resistors because you have stiff legs on them, and we can easily poke them down the holes here. Yeah. So let's just switch it off, put the resistor in here, and switch it back on. It should just start. Yeah. Okay, that's grounded that. So what happens now? Yeah, started. And it's bleeping. Bleeping like there's no RAM in it. It's interesting. Let's get some RAM. Okay, so yeah, I've got some couple of strips of DDR3 here, and it looks like this says DDR2 and DDR3, and these green slots appear to be the DDR3 slots. Yeah, so because they won't fit in the other ones. So it says 2000 plus, these say 1333, but that's what's going in there. So what happens now? Switch it on, and it doesn't bleep, and it doesn't start. There's some LEDs lit up down here, but they were lit before, like 2 greens, 2 yellows and 2 reds. Oh, something went click. Probably the speaker. Oh, something, it's doing something. Can you see it? It's like it's trying to boot. It's interesting, isn't it? Well, there seems to be some sort of problem with the 5-volt standby, because I can't find voltages where I'm expecting to them. Yeah, on here there needs to be some sort of standby on here, and some sort of standby on here to start it, and it doesn't start. But if I force it to start, then it actually tries to boot to some extent. The fan wasn't spinning, but it did try to boot. Let's check the RAM back out, see if it bleeps again. Try that. Switch power on. No, nothing happens. Not this little. Oh yeah, looks like I got a bad connection just on the resistor. I got stuck down the green wire. Yeah. It doesn't bleep. No, it doesn't bleep. This is acting very strangely. The speaker's connected. Yeah. The wires fell off it. Well, we've stopped it bleeping, guys. That's rather bizarre. Power on. Fan isn't spinning. These LEDs are lit. This is now on 0, 0. Whereas before I think it went C1 when it bleeps. We've broken something. So let's have a look at what's on Vcore. What have I got on Vcore? Something's changed again, obviously. Okay. Let's can you see? Yeah, you can see that, can't you? Let's have a look on Vcore to ground. What's what I've got here? Switch it on. To hell with it. Switch it on. And let's have a look. The junction of the FETs. Yeah. I'm on voltage range. Yeah. I've got no Vcore. I've got no Vcore. But I must have had Vcore before because it booted up. I can't say we can have tried to boot up without any Vcore. 3.3, 12, 5. Obviously, they'll come from the power supply anyway. 5-volt standby. That's a bit warm. It's not hot. A little bit of warmth in it. This is a very fun one. I'm not sure what all these LEDs are for either. Green, orange, red. I say when it did power on before, the fan started and it would bleep, 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 bleep. So something's happened. Something's not the same. I think what we need to do is we need to try and trace why we've got no standby voltage coming down here. Yeah. So let me see if I can actually find a data sheet for this first and see where VCC should come into here. I'm thinking probably somewhere on here there's going to be a voltage regulator that has 5 volts coming in and nothing coming out, yeah? Maybe, I mean, there's 2 of them here to start with. We can have a quick look. See if we can just find something on any of these. Touch that wet bleep. What's 0.4 volt? 1.5. Seems a bit strange. I'm seeing some strange voltages on this as well. I mean, like 0.46 volts doesn't seem right. 1.5 seems reasonable. Don't see any. I see 1.5 coming in and 0.46 going out. I think there's something wrong. Something wrong with the standby. Something wrong with the standby voltage. That's the first thing. Okay. Let's take the resistor back out from here. So it's just got 5 volt standby on it. Let's have another look. So we can just figure out what I've got on where, yeah. Now there's nothing on here. So they weren't coming from standby. Some more over here. The buck regulator. This is probably a VRAM, to be honest. 1.56. Something on that one. That's obviously got power one way, the other coming from standby. Standby. What else can we see around here? Any more? Yeah, a few more down here. Voltage regulator, another one over here. What's on these ones? 0.6, 0.4, 1.5. There's all sorts of odd voltages here, isn't there, don't you think? Like some like really odd voltages on this thing. This is one I could probably be doing with a schematic or a board view to start making some sense. I still can't figure out where the 5 goes to. It's not here. Nothing close by here I can see. There's some sort of regulator thing here. There's a capacitor but near it. No, nothing there. Where else can this 5 volt standby be going to? I've looked at those, I've looked at those, I've looked at this. Another thing over here, but I don't think that's anything to do with it. No. Some more here. Buck regulator coils. Is there anything going on around these? Oh, some more regulators here. Not on these ones. Nothing. No. I wouldn't expect 5 volt standby go through a big buck regulator anyway. I've got a good. I might not have had a good ground. I was just checking them. Let's just go back again. No. 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 Well, I've looked around all the obvious places I can think of, and I can't figure out where this 5 volt standby is going. apart from the fact I've got 3.3 volts on the switch, which is a kind of indication it's going somewhere. Oh, 5, that's on the on-off switch, yeah. Five volts. Did I have 3.3 before? Can't remember. 5 volts. That's not unreasonable to be 5 volts. Okay, what I'll do is, guys, I'm going to see if I can find a board view or a schematic for this. I'm also going to see if I can find a data sheet for this, yeah. And then from that we might have, you know, some starting points on where to actually start to look at this, rather than, you know, I wouldn't say I was poking around aimlessly. I was trying to find out where this 5 volt standby effectively goes to. I was kind of looking for a voltage regulator with 5 volts coming in and nothing going out. You know, as a starting point. Yeah, but I can't find that. So okay, let's see if we can get some more information to help us to progress with this one.